this is Mr. Reese, and welcome back to Reese's Pieces Math Mnemonics. Today's lesson is going to be on the calculus topic of solving differential equations. If you take AP Calculus AB or BC, you will be covering this, and it will be on the AP exam, I guarantee. So, I have a memory device for this that's going to help. Now, the reason I came up with this topic has a lot of steps involved, and you will see we're going to go through two examples today. But this memory device can help you kind of break it down and take it step by step. So it's separate, integrate, hesitate, initiate, and then you solve for y or whatever variable last. So the rhyming part comes in the beginning. I have a little hand motion for this. Separate, integrate, hesitate, initiate. So you separate the variables, you integrate, anti-differentiation, and then hesitate, that's just, it rhymes, but it's like pause, wait, don't solve for c yet, and you'll see what I mean when I go through. And then initiate means use the initial value or initial condition, and then you solve for the variable last. So let's look at this example, which was from, or similar to one that was from an AP exam a couple years ago. Use the separation of variables to find y equals b of t, the particular solution to the differential equation given here with initial condition b of 0 equals 4. Initial condition is just basically an ordered pair. This is in function notation, but if you don't like it, you can realize it's basically 0, 4, it's kind of like x, y. In this case, our letters are t for time, and then b of t is like the y value. But here's what we'll go through now. So when I say separate, you have to separate whatever variable I have. This one has a b, this has a t. So the dt is on the left side. I need to multiply dt to each side to cancel that, and at the same time I need to get this b over here. And so I times both sides by b and cancel that. So then we are left with capital B, dB, and if you're already in calculus, you know d stands for derivative, so derivative of b, equals t plus 1 dt. So after I do the separate, I just kind of step back and I check, did I separate the variables? So I have the b and the dB, so those match on the left side, and I have a t plus 1 and the dt on the right. So after you separate, then you integrate. And there's the integral symbol, and you integrate both sides. And for this video, I'm going to assume you already have some basic integration techniques. When you integrate capital B, you're adding 1 to the power, so it's b squared, and then divided by 2, equals, and when you integrate t, same idea, you add 1 to the power, so t squared divided by 2, and then 1 gets the variable t, so it's just 1t, and then you put the constant at the end. So basically this is the antiderivative of that, this is the antiderivative of this. So we already did separate, integrate, now it's the hesitate. Some students want to solve for the c right away, but we actually want to initiate first. Initiate is just the rhyme that helps you remember we need to use the initial condition. So what's our initial condition? 0, 4. So the t is 0 and the b of t is 4. So we're going to plug in 0 for t, which would be right here and here, and the 4 for the b. So actually I'm going to come up here to save space. So 4 squared over 2 equals, and then yes, the 0 will wipe out that part, but I'm still going to show it really quick. So when I plug in 0 for t, I get this, so 16 over 2 is 8, and all that's 0, so c equals 8. So that's why it's important to do the separate, integrate, hesitate, initiate. By hesitating, using your initial condition, you're finding the c value, and now the last step, this says solve for y, which I'm going to do an example next, but it could be solve for whatever variable is here on the left side. So now what I do is I take the c value and I plug it back into this, and then I will solve for b. So let's do that right here. So we have b squared over 2 equals t squared over 2 plus t, and now my c value I found, it's 8. So I use my initial condition to do that. Now the last thing, the very last step, the one that doesn't rhyme, I'm solving for y or b or whatever variable is here. So we use some algebra skills, we times each side by 2, those cancel. Obviously we can distribute the 2 here to every single term on the right, and so I'm left with b squared equals 2 times that, and I'll cancel that 2, so t squared plus 2t, 8 times 2 is 16. And then from algebra, we know when we're solving to cancel a square root, to cancel a square, we take the square root, and remember we get 2 answers. Now, I've been just keeping capital B in there, but now that it's by itself, I can use the function notation b of t, because our variable is t, so it's like f of x, b of t, so in terms of t, and that is going to be plus or minus the square root of t squared plus 2t plus 16. Remember, when you're solving algebraically, and you're solving by taking the square root, you get 2 answers, plus or minus. So now, the thing with differential equations, and when you're solving them, they're always going to ask for a particular solution. That's singular, 1 answer, not 2. So we have to decide which one it is. And I will tell you, if it's a multiple choice question on the AP exam, AP Calculus exam, you're probably going to have both those, and you're going to have to decide which one it is. Well, basically, you're supposed to take your initial condition, plug in 4 there, plug in 0 there, and see which one gives you a true statement. But the shortcut, and it works every time, you have positive or negative, we look at our initial condition, whatever the y value is. If it's positive, that's my answer, because remember the y value is the b of t. So if it was negative, I would take the negative one, but we are going to take the positive answer. So our final answer is the positive square root t squared plus 2t plus 16. And we're done. Now we're going to do one more problem. This one's going to have y and x involved, so I tried to do one that has different letters. But here we go. So the wording on the question is sometimes a little different. So this one says solve the differential equation. There it is. It's an equation involving a derivative, dy over dx, to find the particular solution again. So singular, 1 answer. And here's another hint. You're trying to find the particular solution, y equals f of x, and they're giving us dy over dx. That's a derivative. That's the original y. So that would be a hint. Oh, I got to take the antiderivative, go backwards to get to this. And I'll show you for this one how the separate, integrate, hesitate, initiate works. So we write this down first, and I need to separate the variables. So I have a dy here and a y here. Basically, if you have y and x, you want y on the left, x on the right. So let's get rid of this dx by multiplying dx to both sides. And at the same time, we can get rid of the y. Usually I would normally divide by y. I'm purposely doing timesing by 1 over y. You'll see why in a second. So I'm left with 1 over y dy. So all the y's are on the left. And it's better to have it like this than having the y underneath there. And then this is 5, those canceled, and there's the dx. So we separated, and now we integrate. Separate, integrate, hesitate, initiate. All right, so the next step, this is a formula you should know. I'm not going to teach it to you today, but you should know the integral of 1 over y is the natural log absolute value of y. And remember, when you take the antiderivative, integrate, this symbol goes away and the dy goes away, and that comes out, and that's the formula. This one, when you have a constant and you integrate, you're just going to put an x after it and then the plus c at the end. Now, separate, integrate, hesitate, initiate. A lot of students get eager and they try to start solving for y right here, but then your answer has a c in it and it gets messy and sometimes can throw you off. So we are not going to do that. We're going to hesitate, initiate, look at our initial value, x and y. So we plug in x is 0, plug in y is negative 2. So I'm going to do this in green and go back to the blue. So we have ln, absolute value of 2, equals 5 times 0 plus c. Absolute value obviously brings that out as positive, and then that's 0, so it goes away. So c equals ln of 2. Sometimes your answer for c is not just a regular number. It might be natural log of something, which seems confusing, but it's not that bad, and I'll show you what we're going to do next. So now we did separate, integrate, hesitate, initiate. We found our c. Now I go back and I plug the c value in. So the left side we have ln, absolute value of y, and over here we have 5x plus c, which happens to be ln of 2. So now the last step is solve for y. So we've done all the other things, and from your algebra and pre-calc skills, you should know how to cancel a natural log. The inverse of natural log is e, the natural base. And it's a base, so it goes lower. So I call this exponentiating both sides. So if I exponentiate the left side, here's the equal sign, I got to exponentiate the right side. So I do it once here and once there, and these cancel. Now I have to do a little side lesson. This is the kind of problem that shows up on the AP Calc exam a lot, and a lot of students will have trouble with this. So let me take you back in time really quick to exponent rules. If I did x squared times x to the 7, most students would say x to the 9. But how do we get that? We are adding the exponents. When I multiply the same base and put a single base, I add the exponents. Well, we can go backwards too. If I had x to the 2 plus 7, I can split that apart and write it as x squared times x to the 7. Look at this and look at this. This is e to the something plus something. I'm going to make that a different color so it stands out. So now what I'm going to do is rewrite this using this exponent rule. E to the 5x times e to the ln of 2. Based on this, I can do that same property here. So when it's addition, it actually becomes multiplication. Now I have 2 of the e's, and then this part now is just absolute value of y. Those cancel. So over here, now this one, e and ln, get a cancel here. So this 2 will just come down, and we're going to put that in front right there. So we're almost done. Hang in there. So absolute value of y equals, the 2 comes down in front, and I have e to the 5x. I need to get y like by itself, out of the absolute values. Here's another little side lesson on algebra. So if I had, I'm going to do a simple little thing. Absolute value of x equals 4. Technically, I could put a negative 4 inside there, and that would come out as 4. Or a positive 4 in absolute values would come out as 4. Anything in absolute value always comes out as positive. So whatever's inside here, this y value, when I drop the absolute values, could be positive or negative. Think of this again. If I'm solving for x and it equals that, it could be positive or negative. So technically, my two solutions for that are plus or minus 4. So when I drop the absolute values, I have a plus or minus. So our first example, remember we saw it, we took the square root, that had a plus or minus. And when I have absolute values, I get plus or minus. Those are the only two situations in these solving differential equations where we get a plus or minus answer. And they love to use these on the AP exam. So now we have to decide, okay, it's got to be one of those, a particular solution. Look here. Look at your y value. It's negative, so I take the negative answer, and I'm done. And that is our particular solution. We started with dy over dx. Now we have y. That's what they were asking for, and we're done. So thank you for joining me today. If you like what you saw, leave a comment, subscribe to my channel. I'd appreciate it. Reese's Pieces Math Mnemonics.